Okay, today we are doing Module 3, Lesson 2, where we're still working with equivalent fractions, and now we're looking at when we add fractions together with the same denominator. So, if we're looking at this equation, 4/9 plus 1/9, they're asking that we show each expression on a number line and then solve. So we're going to first draw our number line. And we're starting with 0 because we're doing addition. And so they're saying 4/9 plus 1/9. Now, because my denominator is 9, that means that I'm going to be having my number line broken up into ninths. So if I say that this is equal to 1, and actually I prefer to label them on the top when we're talking about fractions. If this is equal to 1, the space in between 0 and 1 is going to be broken up into ninths because my denominator is 9. So we'll do 1, 2, 3, 4, 5, 6, 7, 8. So now I have ninths split up between 0 and 1. If I continue this on, and I said this was equal to 2, I would also split this into ninths. 1, 2, 3, 4, 5, 6, 7, 8. We're going to pretend that they're equal spaces. Okay, so now I'm doing 4/9 plus 1/9. So I'm going to count out 4. 1, 2, 3. 1, 2, 3, 4. So this was me adding 4/9. And then I'm going to add one more ninth. And then I'm going to look to see where I got. So now I'm at 1, 2, 3, 4, 5. So I'm at 5/9. So the math that I just did was 4/9 plus 1/9. And then I ended up with 5/9. Notice that my denominator stayed the same because I'm looking at the portion of ninths. That's how big my pieces are. And my numerator increased because I added the 4 and the 1. Let's look at one more example of this. And so the one that we're going to do now is D, which is 2 times 3/5 plus 1/5. And you might be a little confused at first because you're seeing this 2 times, and we haven't multiplied our fractions yet, but it'll make sense when we start doing the actual number line here. So let's draw out the number line. And again, I'm going to start at 0, and I'm going to go till about 1, and then I'll also add a 2. And when I'm looking at these fractions, I'm noticing that they are fifths. So that means I'm going to split up my number line into fifths. 1, 2, 3, 4. So now I have 0, 1, and 2. I try to make the whole number hashes a little bit bigger so we can kind of see. And I have it broken into fifths. Now, to represent 2 times 3/5, I'm first going to show 1 3/5, which is here. 3/5. And then because it's 2 times, that means there's 2 copies of 3/5. So I'm going to do one more 3/5, because really I know that 2 times just means 2 copies of. So 2 times 3/5 is the same thing as 3/5 plus 3/5. So I have 3/5, 3/5, and then 1/5. So when I'm looking at this, you can see here on my number line that I've got kind of 2 options now to count it out. I can just go on the bottom and count the fifths. I have 1, 2, 3, 4, 5, 6, 7. So I have 7/5. Another way I can look at this is I can see that it's at the 1 whole, and then so I know it's 1 whole, and then from the 1 whole, I have 1, 2 more fifths. So I can get 1 and 2 fifths. So you have 2 different options here when you're writing your answer. You have what we call a mixed number, which is generally how we prefer to write our answers here. Or we have this, which is the 7/5, and that is called a fraction greater than 1, because my numerator is bigger than my denominator. So that's a fraction greater than 1. You also might have heard that called an improper fraction before, but you'll hear the term fraction greater than 1 or improper fraction, and they mean the same thing. So you have 2 ways, 7/5 or 1 and 2/5. They give you the same actual numerical value. look at number 2. It says, express each fraction as the sum of 2 or 3 equal fractional parts. Rewrite each as a multiplication expression. So they want 2 or 3 equal fractional parts. So if I look at 6/11ths, and I think about that on a number line. We'll start at 0, go to 1, and 6/11ths, the denominator is 11, so I'm going to break them into 11 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to mark off 6. So that's 1, 2, 3, 4, 5, 6. So this is 6/11ths. And they want me to rewrite 6/11ths as broken up into pieces. So I know that I can write 6/11ths as 1/11th plus 1/11th plus 1/11th. And I would have 6 of them. 1, 2, 3, 4, 5. That is one way of writing 6/11ths, because when I add those all up, I'll get 6/11ths, right? I have 1, 2, 3, 4, 5, 6. Those are my 1/11ths. If I'm thinking of other ways I can write 6/11ths, well, I can write it by 2 plus 2 plus 2. That equals 6, right? So I can do 2/11ths plus 2/11ths plus 2/11ths equals 6/11ths. And then another way that I can add up to 6 is I can do 3 plus 3, so 3/11ths plus 3/11ths. Notice that I'm only using numbers with the same numerator on the top because this is giving me the equal part here. They want equal fractions. Yeah, I can say that 5/11ths plus 1/11th is equal to 6/11ths, but that's not an equal fraction. I think these are all of my equal pieces that I can do. And when I go back to my directions here, when they say 2 or 3 equal parts, you can see here that 1/11th plus 1/11th plus 1/11th, etc. That's made out of 5 equal parts, right? Because I have 1, 2, 3, 4, 5, 6 equal parts. So I know that this is too many pieces. But 2/11ths plus 2/11ths plus 2/11ths is 3 parts, and 3/11ths plus 3/11ths is 2 parts. So either of these two answers could work for part A. Because 2/11ths plus 2/11ths plus 2/11ths is 3 equal fractional parts, and 3/11ths plus 3/11ths is 2 equal fractional parts. So I'm following the directions there. So all I'm doing is I'm rewriting 6/11ths in almost calling it like the sum of an addition problem, and I'm trying to see which add-ins together equal that 6/11ths. If I was going to do part B and not do it the number line, it says 9/4. So if I think of ways that I can add fractions together to equal 9/4, I know I can do the same thing here where I do 1/4 plus 1/4 plus 1/4 9 times. 1, 2, 3, 4, 5. But I know this isn't going to fit. 1, 2, 3, 4, 5, 6, 7. Oh, so many. Because they want equal fractional parts. So I know that one's wrong. I need to think of ways I can divide 9 and have them equal the same thing. I think the only way I can do that is 3. Because I can do 3/4 plus 3/4 plus 3/4. And when I add those together, I will get 9/4. That's the only factor of 9 that when I add together, they're equal. It's all 3s. Otherwise, because 1 and 3 are 9's factors. Otherwise, it's going to be 4 plus 5, and those aren't equal. So I get too many add-ins when I'm looking at 1/4, but when I do 3/4, I get 3/4. So my final answer would be this. Again, I'm looking at my 9/4 as kind of my sum, and I'm trying to see what things can I add together to equal 9/4 that fits my clues of having it be equal fractions, so it's the same fraction repeated, and then I also should only have 2 or 3 copies. Okay, last one. Express each of the following as the sum of a whole number and a fraction. So the sum of a whole number and a fraction is another way of saying mixed number. So they want us to rewrite 9/5 as a mixed number. So if I do that on a number line, first I'll show you on a number line, then we'll do it non-number line. I get 0, 1, and 2. My denominator is 5, so I'm going to break it into fifths. 1, 2, 3, 4. 1, 2, 3, 4. And I know my number line's not perfect, but we're going to pretend it's equal parts. And I'm going to show us where 9/5 goes. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So right here is 9/5. So when I look at my number line, I can tell that 9/5 has one whole, right? There's my one whole, and it has 1, 2, 3, 4 fifths. So I can say that 9/5 equals 1 and 4 fifths. So that's how you can solve it with a number line. Another way you can think about it is that if I had 9/5, I know that I can take out 5/5 from 9/5 because 5/5 is really equal to one whole. Because my numerator and my denominator are the same, they simplify to be one whole. I also know that if I take away 5/5 from 9/5, I'm going to end up with 4/5 left over because 9 minus 5 is 4. So I can say that a way to go from this fraction greater than 1 or improper fraction to a mixed number is to pull out my 5/5 and see what I have left over. So I get 1 and 4/5. The third way, so we'll call this way number 1, we call this way number 2, and then the third way that you can find go from a fraction greater than 1 to a mixed number is by doing division, because I know that fractions, this little fraction bar is the same thing as a division sign. So 9/5 is the same thing as 9 divided by 5. So I can do a division problem of 9 divided by 5 and say 5 can go into 9 one time, and I get 4 left over. So I get 1 and 4 out of 5 as my fraction. So 9 divided by 5 is 1 and 4/5. So there's kind of 3 ways you can go from a fraction greater than 1 to a mixed number. There's using the number line, there's almost making like a fraction number bond, and then there's division. And you can do whichever way makes the most sense for you. I'm going to show you and practice with this last one. So 7/2. If I was doing 7/2, I can do 7/2. I can take out 2/2, and then I'm left with 5/2. So that means I can take out another 2/2, and even another 2/2, and then I end up with 1/2. So I should get 3, because this is 1, 2, 3, and a half. So that can be kind of a little messy there. If I was doing this division style, 7/2 is 7 divided by 2. 2 goes into 7 3 times to get 6. When I subtract, I get 1 as a remainder. So now I have 3 and my remainder over my divisor, 1/2. So 7/2 is the same thing as saying 3 and 1/2. So you're basically seeing how many 2's can you take out of 7, because we're taking 2/2 out of 7/2. So we're taking those repetitive 2's, and we see our remainder that's left. You'll find that as your fractions get bigger, you'll want to do the division strategy, because you don't want to have to take out and do multiple subtraction pieces. But if with smaller fractions, the subtraction fraction bond way might be the way to go for you. Lots of ways to look at fractions today, and simplifying fractions greater than 1 to whole numbers, looking at how fractions can be broken down into pieces, and then also adding fractions together with the same denominator. So hopefully we have a kind of a bigger idea of equivalent fractions and being able to add them together and manipulate them a little bit.